And have you studied about the eye defects, vision defects?
No, sir.
You haven't studied the vision defects. What about the structure of eye? Rumasa, right? The right pronunciation.
Yes, sir.
So have you studied about the structure of eye? You unmute yourself, okay? Okay, it's the class 9th, right?
Yes, sir.
Yes, sir.
Okay, okay, my apology. My apology, my apology. My apology. So what did you study in class? Which topic you are studying? It's first class with us, right?
Yes, sir.
Yes, sir.
So what did you study till now? Did we study the rest and motion? Newton's law?
No, sir.
We didn't study the Newton law.
No, sir.
So I was not aware about you guys, okay, and I didn't get the content or topic where to start. So can we start with Newton's law?
Yes, sir.
What about Rumaiza?
Yes, sir.
So kindly don't
Yes,
mute
sir.
yourself. Don't mute yourself. I am a bit habituated with background noise. I love to listen that. So first of all, tell me what we mean by displacement. Have you heard about displacement?
Yes, sir.
What
Yes,
is
sir.
displacement?
The shortest
shortest
distance from
distance
point A
between-
to
Okay,
point A
that's
to point
good.
B.
Okay, that's good. And what is the distance?
The actual length of the path covered by a body.
Okay, the actual distance and displacement is the shortest distance between 2 points. So following that, can we define the velocity?
Yes, sir.
What is
Yes, sir.
velocity? How will define the velocity?
The displacement of a body per unit time.
Okay, you said displacement, then displacement per unit time, right?
Yes,
What
sir.
about the speed? What about the speed? This is distance over time. Not the point?
Yes, sir.
Yes, sir.
Okay. So basically, what is difference between a speed and velocity? Do you know anything? What is difference between a speed and velocity? What is difference between a speed and velocity? Have you heard about? Yeah. Go ahead.
So speed is a scalar quantity and velocity is a vector quantity.
A scalar. And this is vector. So what does it mean? It's a scalar, it's velocity, then what is our business? What to do with this? Both is a measure of velocity, right? The speed is also the measure of velocity, and velocity is also the measure of velocity. What is the connection between these two? Is there any connection? Somewhere an ant is moving, right? Somewhere
sir.
an ant is moving like this. Okay, this is the motion of ant, and one is motion of some object from north to south or south to north, giving this direction. It has magnitude as well, 5 meters per second, and this has also the magnitude, say 0.5 meters per second. It has direction, but it doesn't possess the direction. Got the difference?
Yes, sir.
If you say that you are going from, you all are from Indian subcontinent,
Yes, sir.
which city, Rumaiza?
Maharashtra.
Maharashtra. Okay, Maharashtra. What about Amal? Amal. Is Amal or what? It's like this. Amal, from which city you are? Okay, so Rumaiza, I will give you an example that we are going from Church Gate to, from Church Gate to where you are going. Suppose we are going Bandra. From Church Gate to Bandra. Okay, with a speed of 100 kilometer per hour. So in which category you will put it? This is velocity or acceleration? Sorry, velocity or speed? We are heading toward Bandra from Church Gate with 100 kilometer per hour. So this is velocity or speed?
Speed.
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 Speed. Okay, if you are going from, what can I say? No. Dogri to Bandra. Okay, Dogri to Bandra with 110 kilometer per hour. This is a speed or velocity? Do you know the Dogri? You have been in Maharashtra?
Yes, sir.
No, sir.
Rumaiza is from Maharashtra, so I asked her a native place. She told me from Maharashtra, so I started giving her example related to the city or something. You did, Amal, you didn't responded, so I'm sorry. So see, in this example, we have magnitude 100 kilometer per hour, okay, and direction as well. If any quantity has magnitude and direction, then it is vector quantity, right?
Yes, sir.
So now tell me speed or velocity. What?
Velocity.
Velocity.
Velocity. Is clear?
Yes, sir.
Okay. So can you give me an example of speed? Any example of speed? Amal, from which part of India you belong to?
Sir, Kerala.
Kerala. Okay. Which city?
I'm not sure, sir.
Sorry.
I'm not sure.
Okay, you never been there, right? Okay. So wandering on the Kochi beach or the Calicut beach without any intention, without any purpose, is a speed or velocity. And Rumaiza, for you, roaming here and there at Haji Ali. Have you been there?
So your voice was stuck in. Can you repeat again?
Okay. I'm saying that roaming around Haji Ali without any purpose is a speed or velocity.
It's a speed.
A speed. If you have no purpose, means you have no direction, which way you are going. So you have only a speed. So it's being called velocity, right?
Yes, sir.
So what,
Yes.
it's okay, clear?
Yes, sir.
So
Yes.
I would like to ask, what is instantaneous speed or instantaneous velocity? Can I rub it?
Yes,
Yes,
sir.
sir.
Okay, so do you feel anything to note from this slide?
No.
No. So what do we mean by instantaneous speed or instantaneous velocity? Instantaneous velocity, tell me. What
It
is
is about
average
how
velocity?
fast.
Acha, okay. What about instantaneous velocity?
Instantaneous speed is about how fast an object is moving.
Okay, so this is position time graph, time and position. Okay, this is position by x. Rather I will write position. Okay, that will be fine. This is time, and this way is position. Position time graph. Okay, so position time graph will give you velocity, right?
Yes, sir.
So
Yes, sir.
see, I'm drawing this straight line. Okay. So
Yes.
this straight line travel equal distance in equal time. Okay. This travels equal distance in equal time. So what we term it? Uniform.
Uniform motion.
Uniform motion. We say uniform speed or velocity, right?
Yes, sir.
If in equal interval of time and objects cover equal distance, it's called uniform speed of motion. Can you write it in your own word? Are you familiar with uniform speed?
Yes, sir.
Yes, sir.
Okay. What is it?
When an object
When
travels equal distances in equal intervals of time.
Okay. So what is its unit?
meter, sorry, sir.
Meter per second.
Okay, right.
Right.
So what is average speed? Average speed? Average speed? What is average run rate? Are you guys familiar with cricket?
No,
Yes,
sir.
sir.
So what is average run rate? So average run rate in first 5 hours, 0 to 5 hours. What does it mean? What does it mean? What we mean by average run rate over 0 to first 5 hours?
I don't know, sir.
Suppose in first hour, someone make 10 run, and another hour, 2 run, it next hour, 0 run, and then next hour, 20 run. So this is the fourth hour, and then in next hour, suppose again the 10 run. So it's not uniform. The scores is not uniform. Okay. But what is the arithmetic average? We will add 10 plus 2 plus 0 plus 20 plus 10. Is the 5 entry, we'll divide by 5. Right? And we will get average. It means that the motion was not uniform all along the path. Okay. Somewhere speed was 10 kilometer per hour. The next part, it was 2 kilometer per hour. Then again, there was some stoppage. Then again, 2 kilometer per hour and 10 kilometer per hour. So we calculated the average and said that average speed is somehow 5, 10 or 20 kilometers per hour. So average speed, we have to, we are not asking about the entire journey is smooth. Somewhere our speed was higher, somewhere it was lower. So average is arithmetic average is the average speed, right?
Yes, sir.
Clear?
Yes. Sir, can I go pray?
Yes, sir.
Sorry,
Can I go pray Maghrib?
you are going for Maghrib. So you both are going? You both are leaving?
No, sir, I forgot.
No, no, sir. I'll be in the class. I'll just go for 5 minutes.
Okay, okay.
Yes.
So Rumeza, you are here, okay? These concepts are
Yes, sir.
clear?
Yes, sir.
Okay, so what? Okay, so I am removing it. So velocity and speed is clear to you?
Yes, sir.
Instantaneous speed, instantaneous velocity, average velocity, is everything okay?
Yes, sir.
So if we have to calculate the average velocity, how will you calculate this? If the initial object of that any object, initial speed of an object is u0, and final speed is uf. So what will be the average velocity in this case? What will be the average velocity in this case? This means average mark. Okay, if we will write something on the top, it means average. Average velocity. Actually, before starting the Newton's law, we must have to understand what is velocity, what is acceleration. Okay, then only we will be able to understand the Newton's law, right?
Yes, sir.
Okay, that's why we are investing some time in these basic terminologies. So what is average speed for this situation?
So average speed is total distance by time.
Okay,
So
total distance by total time. Okay. So in our situation, I said that an object having initial velocity u naught and final velocity u final. For this case, what will be the average velocity? My question is simple. The situation is clear. This particle
yes,
has initial velocity u naught when we measure at some instance of time. then the next time we measured that it was UF. So what will be the average velocity for the given situation?
0.
Now, how you calculate it?
Because
If we have to find the average of numbers, say 2 and 3, arithmetic average, how you will find? Average of this number. Average of 2 and 3. What will be the average of 2 and 3? Have you read in mathematics average? How we find the average? Abdul Jabbar. Are you joining right now? I'm audible to you guys. I'm audible.
So
Okay.
can you hear me now?
Yeah. So Romeza, my question was, if we have to say that we have to find the average of two number, 2 and 3, how we will do that?
2 plus 3 divided by 2.
Then 2 plus 3 divided by number of observation, right?
Yes, sir.
So here we have these two numbers. So what will be the average?
2.5.
U naught plus UF divided by 2. You may say that this is 2.5, right? So this is our average speed, right?
Yes, sir.
Average velocity. I'm not talking about the speed. Clear?
Yes, sir.
The average speed is also, you said that is total distance upon total time, right? So
Yes,
if
sir.
this is here the time is already included in this velocity. You may write that velocity is position over time for this one and position over time for this one. If T1 is equal to T2, then T1 plus T2 will become 2T, right? So this is the same thing, what we are going to explore over here. So if position is x naught at t is equal to 2 seconds, and this is x is equal to 5 meter for t is equal to 6 seconds. So what will be the average velocity in this case? What will be the average velocity for
Sir,
this
4
case?
seconds.
Yeah, 4 seconds. So total distance is 5 meter, and this distance is 6 minus 2, right?
Yes, sir.
So 5 over 4. How much it will be? The total distance over total time, right? The total time is 4 seconds and total distance is 5 seconds. So how much it will come?
So 1.25.
1.25, right? It is 1.25 meter per second.
Yes, sir.
Okay. Rumaza, you got the answer?
Yes, sir.
So this is the average velocity. So now move on. Can you define the acceleration?
The rate of change of velocity per unit time.
Okay. Is clear to all of you?
Yes, sir.
Yes, sir.
Okay, now we have a situation. We are throwing a ball from Earth. Let me erase it, then I will put the situation and then I will find your remark. We are throwing a stone. This is the Earth surface or some building. We are throwing a stone upward, a straight one. Okay. We given it a velocity u naught. It reached over here for time is equal to t. So are you aware of kinematic relation? V square is equal to u square plus 2gh or minus 2gh. V is equal to u plus at. Are you aware of all these terms?
Yes, sir. Equations of motion.
Equation of motions. You both are aware of it.
Yes, sir.
So now tell me, we thrown this stone with velocity of u. It reached at maximum height h. So what will be velocity at height, maximum height? What will be velocity at this point? This is the maximum height. My question is velocity at max height. Yeah. This is very basic question. You can
So
understand.
0.
It will be 0. How you guess that it will be 0?
So because the final velocity would be 0.
Final velocity will be 0, right?
Yes,
So
sir.
now if I throw the same ball on Earth's surface, okay, like that. So now it is, so here it will be a stop, right? If a ball we throw with velocity u naught at the final position, when h is max, the ball will stop, right? So
Yes,
this
sir.
will be 0. Okay. So if the surface is horizontal, there is no possibility that ball will return back. Okay. Or maybe there will be possible if it's going to cancel the friction or something. But here in case the velocity will be 0 on the top, and then again it will start falling with under the acceleration of gravity, right?
Yes, sir.
Okay. So can you find how far it will go if we are giving it a velocity u naught? What will be this height? Can you calculate this? I'm just putting you in situation. From next day, we will be starting the Newton's law. So at least I must have some idea how much you people can think. My question is how much distance it will cover if we are throwing it with velocity u naught. If you are done, you may show through the screen if possible. Did you calculate it, Amal? So did you guys study the rest and motion chapter? Have you studied the rest and motion chapter?
Yes, sir.
Okay, so this equation is over there. You might have calculated some relations.
Sorry, sir.
So did you study the rest and motion chapter?
Yes, sir.
So you might have seen all these relations. Okay. You must have done some calculation as well. So my question is that if we are throwing an object with speed u naught and it reaching the final velocity 0, okay, so how much distance it will cover in time t? Let's say time t. How you proceed? Did you try this?
So we'll use the equation S equals UT plus.
S is equal to UT plus half of AT square or minus of GT square. It is being thrown up this side. So this is U not T. This. So we are not aware of time, right?
Yes, sir.
So this might be the relation. If we are not aware of time, we may use the first relation. According to that relation, this will be V square. V square is equal to U naught square or U square minus 2GH, right? So we say that final velocity is 0. So this will be equal to U naught square minus 2. We can take 9.8 into H, right? So this will
Yes, sir.
be U naught square is equal to 2 into what will be the numerical value of 2 into 9.8?
Sir, 19.6.
Rumeza, you agree with it? H, right? So
Yes, sir.
H will be U naught square by 19.6. Okay,
Yes, sir.
it's a
Yes, sir.
simple calculation. So my point was to make you familiar that at the top, the particle will lose its velocity. Okay, velocity will cease and then it will start falling back. Okay. So you must have
Yes.
done a number of problems based on these relations. Or not? You didn't solve any problems?
We did, sir.
We did. So you were not able to calculate it. You failed to calculate it, right? So it's not the time to ask you again some question. May I ask? May I ask some question based on this?
Sure, sir.
Okay, let's see. Suppose a car is moving with velocity of 30 kilometer per hour. Okay. We apply a brake for 5 seconds and the speed goes to 0. Situation is clear? A car is moving with speed U naught, say 40 kilometer per hour. We follow the traffic rule and apply a brakes for 10 seconds, right? And car stops. Can we find the acceleration?
So A equals B minus U by T.
A equal to V minus U by T. Good. What is V? 0. U is
Velocity.
40 kilometer
40.
per hour. And this is in second. So we are in trouble. We are in trouble. We have to change either this kilometer per hour to seconds or this seconds to hour. So which one you want? Because
So
So 40
40
kilometers.
kilometers to, yeah.
DI minus IO nullity. Dimensionality must match. Okay. Then only we will do any mathematical calculation. If dimensionally doesn't match, we can't do anything. Like if we want to add 2 bananas and 5 apples, how much it will be?
7.
2 bananas and 5 apples. Both have the different dimensionality, right? So we can't add it. We can only add 2 bananas with 5 bananas, 2 apple with 5 apple. You can't do like that. Did you get my point?
Yes, sir.
So
Yes, sir.
here one is in hour and another is second. So kindly will you change it in seconds? 40 kilometer per hour you have to change into the meter per second. Will you do it?
Yes, sir.
Yes, sir.
Okay, go ahead. Actually, I thought of teaching you Newton's law, and then I started asking all these basic questions. So we may start from next day Newton's law, okay?
Yes, sir.
Okay, so today just do these basic calculations.
So 11.111 seconds.
So first of all, I
Correct
would
or the
like
same?
to change 40 kilometer per hour into meter per second, okay? So 40, I'm just leaving the 40 along apart. So 1 kilometer is equal to how much? 1000 meter?
1000 meters.
Okay.
Yes, sir.
In 1 hour, there is 60 into 60 seconds, right?
Yes, sir.
Yes, sir.
So 101010. So now we may cancel 2 3 is 6, 2 5 is 10. We may write is at 5 hour 18 meter per second, right?
Yes, sir.
So you may remember that 1 kilometer per hour is equal to 5 by 18 meter per second. Okay. 1 kilometer per hour is 5 by 18 meter per second. So here is 40 kilometer per hour. So we will write 40 as it, and it will be multiplied 5 by 18 meter per second, right?
Yes, sir.
You guys did like you solve like this.
Yes, sir.
This was the same value.
Yes, sir. 5.2.
Okay, so let me calculate it. I'm using calculator. Okay. So what is your answer?
11.111 seconds.
11 point, yeah.
Okay. 11.11111. 11.11. May I'll write only 2 significant digit. Okay. This is
Yes,
meter
sir.
per second. So now put it over here. This is minus 11.11 meter per second divided by 10 seconds, right? The second to
Yes, sir.
second will be cancelled. We will be left with minus 1.11 meter. Oh, how? It's meter per second. Is second is down straight. So it will meter per second square. Got the point?
Yes, sir.
It won't gonna cancel because acceleration is meter per second square. I did a mistake. Okay. So it's 1.1 meter per second. So my take is that acceleration is negative. What does it mean?
It is retardation.
Oh, that's great. So we will stop with this discussion today, and hopefully from next day, we will be studying the new chapter, Newton's laws of motion, right?
Yes, sir.
Do you have any
Yes.
doubt?
No, sir.
No, sir.
Any confusion?
No, sir.
No.
Any question you want to ask about about today's discussion?
No.
No, sir.
Okay, then thank you.
Thank you, sir.
Thank you, sir.
Most welcome.